Hi, this is a quick demonstration of Jbrick. Jbrick is the software that we developed to allow students who are sighted or visually impaired to be able to program Lego Mindstorms robots. In another video, there will be a demonstration of a student running the robot. This runs on the Mac or PC. This has been developed over a period of time, and so this demonstration will show the current version running on a Macintosh. It runs under Java, for those of you that are concerned about that sort of thing. So it doesn't run on the web browser. Instead, you have to download the program and run it. What is open in front of me here on the screen is a sample of code. What I will be doing during this demonstration is sometimes turning VoiceOver on, so that way you can hear the screen reader run. I won't have it running the entire time because you don't want to hear too many people speaking to you at once. So what will be, I have a male voice picked so that way it's easy to pick up between the two of us. So again, I will be turning it on and off at certain periods of time so that way you can get a feel for it. So what I have is a sample of our tutorial file created. The students all individually go through an individual tutorial where they learn the basics of the language. If you're able to see the video, you will notice that the language is text-based, and so it doesn't rely on blocks or visual elements that are dragged around the screen and click together. Instead, the students are required to type. And what we've done to try to make things a little easier is to create libraries so that way it kind of makes some of the commands and things that they have to do a little less complicated, but still they are required to type. And so these tutorials help them with that effect. We have them do that individually, so that way afterwards when they have the challenge, their project selected as a team, they each have their individual skills to be able to do that. So I will be turning VoiceOver on so that way you can get a sense for what the students hear when they are listening to their code in VoiceOver. For those of you that are familiar with screen readers, what I have done is I have turned on verbosity to high to include all punctuation. You have to do that with JAWS as well, because by default it doesn't necessarily give you all of the punctuation, and with text-based programming there's several pieces of punctuation, brackets, braces, semicolons, and so forth, that the students need to be able to hear about. So I will turn VoiceOver on for a little bit so that way you can get a sense for, again, when the code is read to the students, what they are hearing.
Welcome to VoiceOver. VoiceOver on Java, Jbrick window. Jbrick has keyboard focus. You are currently on a text element period.
The first line is blank, so I will be going on to the next line.
Edit text insertion on word, number, new line number, define move underline time 500 new line. You are currently on a tab group period.
So in this case it read one line. I'm not an expert in VoiceOver, but basically what will happen is the students can select to read as little or as much of the code as they'd like. And so if it were to go on and read the following pieces of code, it would read the following lines.
Number, define earn underline time 360 new line. New line. Task main left there and right there in new line. Left brace new line. New line. Repeat left there and far right there in new line. Left brace new line. On FWD left there in OUT underline AC comma 75 right there in semicolon new line. Wait left there and move underline time right there in semicolon new line. / here comma move underline time is replaced by 500 because of the number defined statement at the top of the file period. New on reverend left there in OUT underline C comma 75 right there in semicolon new line. / by having one motor move forward and the other move backwards comma, we can make the robot turn in place period. New wait left there and turn underline time right there in semicolon new line. Right brace new line. Off left there in OUT underline AC right there in semicolon new line. Right brace new line.
So that's the entire program for this small example. If you're able to see the screen, you may notice that some things are capitalized and some things are not, and so that is part of the tutorials to kind of learn when you capitalize certain things, in addition to when you use certain pieces of punctuation. So for example, with the pound define move time, it's a constant that's defined at the beginning that basically sets the time. 500 is milliseconds, so half a second of move time, and turn time is 360, which is 360 milliseconds. So that way the students can gauge, and they can always go back and adjust these things as they go through their program. So basically what's going on here is that a set of lines is repeated 4 times. That's what the repeat 4 does. And so what it does is it goes forward using 2 of the motors for 75 is the amount of power, so it goes actually fairly quickly. And it does that for a certain period of time. It does that for that half a second. And then it goes backwards with 1 motor, so that means it's going to turn at an angle at 75 power, and it will do that for 360 milliseconds. So it's not just a simple back and forth one direction and then the exact reverse, but instead it goes backwards at an angle to a particular period of time for a shorter period of time than they moved forward. So it kind of almost makes like a check mark, if you will, in terms of what it looks like visually. And it does that for 4 iterations in terms of doing that set of code 4 times. And then it turns the motors off at the end. What happens is the students would go through a piece of code like this and they listen to it and they add in their own code. With that, they need to go through and they need to check their code and try to run their code. So what goes on right now is after the student is done, I actually don't have a robot connected, but it's okay. I just won't run it. They will go to the compile menu and they will compile the code, and the program tells them if their code is syntactically accurate or not. So it will tell them, for example, if they might have missed a semicolon, or they might have mistyped a variable or something like that. So I'm going to have VoiceOver tell you what I'm doing here in terms of the compile.
Compile menu for items. You are currently on a menu period. To choose this menu item, press Ctrl-Option-Space period. Compile message window image. You are currently on an image period.
Okay, I'm not quite sure how to have it changed to the box, but it does say the compile is successful, and so the student would know how to do that more than I. And I'm going to hit the OK button.
Now in Jbrick window, to repeat a period. MXC tab group. You are currently on a tab group period.
I'm going to turn VoiceOver off.
Keyboard brightness, brighter.
Oops.
VoiceOver off.
I'm going to talk about a few other items in here. One is, you saw the compile menu. If you noticed here when I pulled it down, the VoiceOver didn't read all of it, but the things like compile and download and so on have keyboard shortcuts, so they can just hit a particular key on the keyboard instead of having to go to the menu, and it does it automatically for them. Okay. The other thing I wanted to show is in the preferences. Students who have some visual impairment but are able to see magnified text, for example, but may have specific visual needs, are able to go through and change all the coloring that is in the tool. And so they can change the background and foreground, how the numbers are themselves for the lines are depicted, and so on. Change the font and those types of things. And so they can adjust all of those. I actually kind of like it for myself in terms of how that's done. So I'm going to leave it. But they can always save that and come back to it whenever they need to. So I just wanted to show you that. The other thing that relates to that, that's also very useful, where'd it go? Here it is under the View menu. You can also increase or decrease the font size, so I'll do that really quick. That way you can get a sense of it. It's one of those things that a lot of students will find very useful. And as you notice that it not only increases the size of the program, but it also increases the line numbers. And in the menu below, where it says compile successful, it also increases that font size. If there were errors there, it would show those line numbers, and the student could click to it and be able to go there. And again, all that text would be the same size. One of the other things that I wanted to show as well, that through a lot of testing we found to be very useful for students, again, that have some vision, is that instead of just having the cursor where a student would type, the whole line is highlighted. So it helps them know which line they're on if they have the vision to do that. In addition, when they jump back and forth looking for errors, again, it highlights the whole line, and so that way it lets it stand out visually to be able to do that. For students that get a little more advanced, the color coding of some of the keywords, like as you notice here, the pound of fine is a different color, the comment is a different color. They can set all those as for what would be easily discernible for them. The other thing too, which actually shows up better on the Mac, or rather the PC side than this Mac version I have, is that when a compile is done, and especially when it's downloaded, actually that's really where it comes in, is that when it's downloaded to the robot, it will beep to indicate that that download has happened. Otherwise, there would really be no way to know, because the robot itself tends to not do anything until you actually activate the program. But it is good for a student to know when their program has been downloaded. That way they know it's ready to go use it. So that's another thing that, that is also included. So I just kind of want to give you a quick demonstration for that. One of the other things that we also have done is we have these line numbers, but we do also have a keyboard, a couple of things to help students know that. So yes, they can count what line they're on, but that doesn't work very well for very long programs. We do have a keyboard shortcut that also indicates to them what line number they're on. In addition to the errors, let's see if I can, let me try a separate video to show the errors with you. That way you can kind of see how that works a little bit better. So let me jump back to Camtasia. Hi again. So I wanted to show you something really quick about errors. So again, this is the same file that you just saw. And what I'm going to do is I'm going to introduce an error. So one of the common things students do is they might accidentally mistype the name of a variable. So for example, I'll just pick move time. Move time was defined up above, and so I will just accidentally just type in an extraneous character, or I'll just put in this X in here. And so what I will do is start VoiceOver.
Welcome to VoiceOver.
VoiceOver on Java, Jbrick, window, edit text insertion on Word, MOVX, after character, X, new line number, define move, underline time 500, new line, number, define earn, underline time 360, new line, task main, left there and right there, new line, left brace, new line, repeat, left there and 4, right there, new line, left brace, new line, on FWD, left there and OUD, underline AC, comma, 75, right there and semicolon, new line, wait, left there and MOVX, underline space. You are currently on a text area, period.
So I kind of stopped it from reading the whole code, but what I will do is I will save my
File,
changes.
menu, items. You are currently closing menu, edit text insertion on Word, space, new line number, define move, underline time 500, new line, number, define earn, underline time 360, new line, task main, left there and right there, new line, left brace, new line, semicolon. You are currently on a text area, period.
Okay, so what I will do is I will compile.
Compile, menu for items. You are currently on a text area, period. Message, window, image. You are currently on an image, period.
So the message is being displayed again. I can't quite figure out how to toggle to it, but it says error occurred during completion or compilation. Check status pane for more information. So I'm hitting OK.
Now in Jbrick, window, edit text insertion on Word, semicolon, to underline, repeat, underline, period. MXC : button. You are currently on a tab group, period.
So what I did was, there's an error that I inserted on purpose, and so it takes me to the pane where it lists the errors. This is common in programming, and so what it is listing here is first the name of the file that you're on, which is fine, and then underneath, and I'll go to that line specifically, so that I'll do that after I've spoken, it will list the error in terms of what line it's on and what error it is. Now the errors, compiler errors, are not always the friendliest things, but you kind of get a sense for where the error is, and basically it's something, it gives the student an indication that they need to look a little closer to see what the error might be. So we can listen to the error.
Error line 10 : undefined identifier MOVX, underline time, button. You are currently on a tab group, period.
So it says it is an error line 10. It's an undefined identifier. It says move X underscore time, because I inserted an X. And so what you can do easily and very quickly to jump to the error is to click or otherwise select the link on the error. And it says error line 10. Actually, I'll move my cursor elsewhere.
Edit
It was
text
already
insertion on
there.
Word. Left brace. New line. Error line 10 colon. Undefined identifier MOVX underline time button. You are currently on a tab group period.
Okay, so I was already on there. But I clicked on it after I moved my cursor out of there so you could see it jump to the line. And if I go to the line itself,
Edit text insertion on Word. Far right therein. After character, space, new line number, define move underline time 500 new line. You are currently on a tab group period.
the student examines it. Oops, actually wrong line. I go down one.
7-5 right therein.
So one of the funny things, or not so funny if you have that happen to you, is that compilers don't exactly always give you the error on the exact line. So you see here it says error line 10, when in reality that one's okay. It's on line 11. So that's one of the things we have the students do, is to go through and to check and see with around that error line, is there something wrong? And
Far
so
right therein.
in terms of the on forward, that one's okay. Okay, but things that are common are they accidentally forget a space, they mistype something, when they should have a number, they have something that's not a number, so on and so forth. So that one's fine. And then go down one line.
Wait left therein MOVX underline time right therein semicolon new line.
And someone would hear that, possibly a couple times, and go, oh, it's move X when I want it to be move. So they go over and erase the X.
Space dot A-I-T left therein M-O-V-E-X
And they get rid of it.
X.
Okay, and then they save.
File menu A items. You are current save. You are currently on a tab group period.
And then they will recompile. It's always good to just change one thing at a time before you recompile, otherwise you're not sure what you did to fix it.
Compile menu for items. You are currently on a menu period. To choose this menu item, compile message window image. You are currently on an image period.
And here the box says compilation successful. So in this case it did fix that particular error.
Now in Jbrick window, to underline repeat underline a period. MXC tab group. You are current new line.
I put it on an empty line just so it would stop talking for a little bit. So you kind of get the sense of the cycle that the students go through in order to kind of get a feeling for working on their programs little by little, which is very common. The nice thing about working with robots is that robots move, and so that way when they're building their programs little by little, they're able to see that it's moving in the direction or at the speed or picking up what it is intending it to. And so it works out very well with working in a team, because that way people can have different roles and they can rotate those roles to be able to do things like design the robot and program the robot and test the robot. And so they all get exposure to these various areas. But this is a program that we use. We are always looking to add new features to it. But this is kind of one that we have in mind that has worked for us for a while here. And again, it does work with the Lego NXT robot. There's a subsequent video that shows you an example of a student robot that they built, and it's running for the final project demonstration. Thank you.